Last class you learned about the measurement of a radian, and we just did this what is a radian activity to really nail it down that we are now measuring angles not in degrees necessarily, but sometimes in radians. So let's talk about some applications of this radian measure. Since arc length is used as a part of the ratio that creates the angle measurement for radians, we can work backwards to find this arc length. An arc of a circle is the part of a curve or the portion of a circle contained by a central angle theta. It's like the crust of the pizza pie slice. The length S, so we're using the letter S for arc length. The length S of the arc intercepted on a circle of radius r by a central angle of measure theta radians is given by the product of the radius and the radian measure of that angle. Basically saying we can use this formula to solve for arc length, which is essentially the same formula we used last class. Since theta was S divided by R, we know that arc length is R times theta. We just basically solved the formula. Instead of setting it equal to theta, we set it equal to arc length. So it's the same formula, changed. So let's see what this looks like. Remember, we're getting the pizza pie crust. That's what we're measuring here. A circle has a radius of 18.2 centimeters. Find the length of the arc intercepted by a central angle having each measure. If we're doing this, 3 pi over 8 radians is exactly how we want it, because then we have the radius of the circle and we have the theta in radians. So all we have to do is fill in that formula where we would say arc length is equal to r times theta, where r is 18.20 and theta is 3 pi over 8. Easy peasy, right?
Should be.
Should be. This is a calculator question, which I can see based on the number of calculators still over here. Not everybody grabbed one. The questions for the most part are going to ask you for a rounded answer. But we're going to give 2 answers on our notes just so you can see, in case it says this particular thing, what I mean. If I ask you for this in terms of pi, if you see that phrasing, which may or may not show up for you, you type everything in your calculator except for the pi. So we're going to type 18.2 times 3 divided by 8, or times 3/8. Not the pi. It's there now. Oh. Which means that S is equal to, in terms of pi, 6.825 pi centimeters. But if it just asks you for an estimated number, you can press the pi button, which means then we would do 18.20 times 3 pi divided by 8. Or just take that number we just got and multiply it by pi with the pi button, not 3.14. Please use the pi button. Yes? Oh, radians, but it doesn't actually change anything because you're not typing sine or cosine or tangent. That's the ones that are affected by being in the correct mode, but that's a good thing to think about. That way you're always looking to see what mode we should be in. We also know that this arc length is equal to 21.4414 centimeters. So if you want it in terms of pi, basically don't press the pi button and slap the pi on there at the end. And if it don't ask for it in terms of pi, which I think most of it does ask you to round, which means press the pi button. But just in case you see that, these are both equivalent to each other, and they're the same. Ooh, but problem. Letter B is in degrees.
Oh, no.
The formula for arc length requires that theta is measured in radians. So before we use the angle 144 degrees, we do need to change it to radians. So what was the conversion last class to change degrees to radians? 144 times, and then there's a conversion factor. That's a great question. Which one is it? 180 divided by pi or pi over 180? Pi over 180. If you want it to be radians, that means you're trying to get pi to show up. So pi needs to be in the numerator. If you're trying to get pi to cancel out, that's when it's in the denominator. That's how I remember this. Now we're not pressing the pi button here because we want it in terms of pi. But what is 144 divided by 180? Reduce that fraction, please. 0.8, can I get it back as a fraction though? Because it's a cube fraction. 4/5. So 144 degrees is 4 pi over 5. But once I have that radian measure, we still are using the same radius for this problem, which means that arc length is going to be equal to the radius times 4 pi over 5, where my radius is 18.20 and my angle measurement in radians is 4 pi over 5. We'll give it in terms of pi and as a rounded number just so we can keep practicing. So 18.2 times 4 divided by 5. Oops, I mistyped. 14.56 pi centimeters. And if we go ahead and press the pi button and multiply by that as well, we'd get 45.7416 centimeters. Make sure you pay attention to how the book wants you to round and or give answers. Like I said, I'm pretty sure for the most part it wants the rounded version, but if you ever see something in terms of pi, that's what I'm talking about. Don't press the pi button, leave pi there.
Oh, so if I would have put the 45, that would still be right?
The 45.74. They're the same number, it just depends on what I was asking for. So if you see that, and this is the phrase, if I say in terms of pi, this is what one I want. If I just say round to the nearest whatever, this is what I want.
Wait, so how did you get the 42? Because I just messed it.
Do all of that except delete the pi.
Let me see. Okay.
Make sense? Okay, second example here. Finding the distance between two cities. So longitude and latitudes, because they're used with degrees and radians, we are going to be able to do some geographical help on maps. The globe, right, is circular. I know it's a sphere, but if we're thinking about it in a 2D way, it's a circle. So finding distance around a circle, oh snap, that's arc length. Latitude gives the measure of a central angle with the vertex at Earth's center, whose initial side goes through the equator and whose terminal sides goes through a given location. Reno, Nevada is approximately, oh, there's a number missing. Oh no, it's approximately due north of Los Angeles. The latitude of Reno is 40 degrees. So I have this here drawn for you, 40 degrees. And that of Los Angeles, the latitude is 34 degrees. The radius of the Earth is 6,400 kilometers. Find the north-south distance between the two cities. So we are trying to figure out, in this tiny little diagram here, the arc length between Reno and Los Angeles. That tiny little thing. So my question for you is, and it's kind of here on your screen if you can even read that, if Reno is at 40 degrees and Los Angeles is at 34 degrees, how much degrees are in between them? 6. It says that on your image, but if you can't read that because it's so small, here's what we did. The angle we're going to find the arc length for is 40 degrees minus 34 degrees, which is 6 degrees. Ooh, but degrees, don't love that. What do we need to convert it to? Radian. And how do I do that? How do I convert it to radian? Pi over 180. So you're just doing 6 over 180, leaving the pi. We'll do this in our brain. What is 6 over 180? Nope, don't reach for your calculator. Do it in your brain. Nope. Let me ask you, what is 180 divided by 6?
I don't know.
What is 18 divided by 6?
3.
Add a 0 to the end. And it goes in the denominator.
Huh?
0.
This is pi over 30.
Yeah.
6 divided by 180 is 1/30th.
What do you get? 1 here?
You can do all of that by flipping it in your head and just remembering it goes in the denominator. 180 divided by 6 is 30, but it should be the opposite way. Use the reciprocal. We also know just from our equation here that the radius of the Earth is 6,400. So if we're finding that arc length between them, now that we have everything, all we need to do is the radius times that angle. So I'm going to do 6,400 times the angle measurement, which was pi over 30. And I just want this rounded to the nearest 4 decimals. Don't worry about leaving it in terms of pi. But we're just doing 6,400, the radius, times the angle. Did you get 670.2064 kilometers?
Sure.
Fabulous. Now notice all of the problems I've done so far. What have I been putting at the end of each of these? Units. Please make sure you're checking your units because that's the number one way to make sure you're actually answering the correct question in these problems. What's up, Joseph?
I'm like super confused.
Okay.
Actually, about how it's 30 because we did the exact same thing above on B.
Yes.
And the way I did it was 144 divided by 180, correct?
Yes.
So why would it be flipped now?
To help you do it in your head. Because when I ask you what is 6 over 180, everybody panics because it's a fraction. But if I ask you 180 divided by 6, you're going to be able to give me a whole number.
So is pi over 30 the exact same thing as
6.
over 180?
It is. Now check in your calculator, make sure I'm right. I was just trying to give you a tool to do it in your head faster than needing to rely on a calculator. But that was a great question. 6 divided by 180, and then reduce the fraction.
If you drop the 0, 3 times 6 is 18, add the 0 back in.
Correct, yeah. Those are the thought things that you can do in your head to do this math without needing a calculator.
34. I was 343.
Oh, because you put the pi. Don't put the pi.
Wait, so what I put in there?
This question says a rope is being wound around a drum, which is very hard for me to say fast, wound around a drum with a radius, highlight that, a radius of 0.8725 feet. We have this in our figure, okay? How much rope would be wound around the drum if the drum is rotated through an angle of 39.72 degrees? If I'm asking how much rope would be wound around the drum, I'm basically asking for this measurement right here, which we know to be the arc length. How much has moved around the drum in that much angle? That's arc length. So we have a formula for that. We know that arc length is r divided by theta, but theta must be in radians, and what is this one in? Yuck. Okay, so we switch it to radians. To switch this to radians, it'd be 39.72 multiplied by pi over 180, which, yes, 39.72 divided by 180. You guys got 331 pi over 1500, yes? Fabulous. So now we have r and we have theta. So we can do our arc length. Wow, I just fully had a brain blast. Okay. R times theta. That means the radius is 0.8725 feet. And the theta is 331 pi over 1500. Again, let's just go ahead and round to 4 decimals. How much rope has actually been moved if that's the radius and the angle that we've moved around this circle?
Oh, pi?
Go ahead, don't leave it in terms of pi. Go ahead and round to 4 decimals.
0.1925.
I got a different number.
You said what pi?
They were using pi, right?
Use pi, yes.
Oh my, you didn't say that.
I said don't worry about in terms of pi. Yeah, that's what I got. 6049. Yes, put the pi in there. Remember, if it says leave answer in terms of pi, that's when you do that.
I got an error.
But if I say round to 4 decimals, go ahead and round. Okay, what's your error? Let's say now we have 2 gears moving around.
Okay.
And they are adjusted so that the smaller gear drives the larger one as shown in the figure. If the smaller gear rotates through an angle of 225 degrees, how many degrees will the larger gear rotate? It won't be the exact same because there's a difference in the radius of these 2 objects. So we're going to split our little problem in half. I find it easier to do this. This first side is going to be the small gear, and this one's going to be the large gear. The things we know about the small gear are that the small gear has a radius of 2.5 centimeters. We also know that the angle is 225 degrees, but don't love that, so I'm going to multiply by that, by what? By pi over 180. And if I multiply 225, well, I guess divide by 180, we'd get 5 pi over 4. So the arc length of the smaller gear is going to be 2.5 times 5 pi over 4. So I have my radius times theta. Cool, we've done all of this already. Let's go ahead and get a number, but we're going to be very, very accurate with this one. So this time, leave it in terms of pi, which means we're going to do 2.5 times 5 divided by 4. Let's just make that a fraction because that's a fraction that actually looks kind of nice. We would get 25 pi over 8. The reason I don't want to round is that we are in the middle of the problem. If you're in the middle of a problem, you don't want to lose specificity of your numbers by rounding too early. So if at all possible, don't round to the very end. This is where leaving it in terms of pi is very important. Now here's the cool thing. With two gears that are interlocked like this, they're going to move the same arc length, even though they have a different radius and thus a different angle. So now we're going to have to use this concept of how far this large guy has moved to, which is 25 pi over 8 centimeters. I guess I should put a unit on here, to then find the angle. What is the radius of the large gear? 4.8 centimeters. So if I wanted to find theta, you actually had a formula for this last class. What was the formula we used to find theta when we were given arc length and the radius? S over R. So we know that theta will be equal to S divided by R. And we know how long it's moved because the two gears have to move the same distance or else his teeth would get all messed up. So S is the same for both of these, but everything else is different. So if we fill in this formula, we know that the S is 25 pi over R, and we know that the radius of the larger gear is 4.8. Why did I put an R right there? That is crazy. What am I doing? Okay. This one, since we are at the end of the problem, we will use the pi button. But again, if it ever asks you not to use the pi button, you do everything but the pi. But let's go ahead and write this in a decimal form. 2.0453? I don't think so.
Wait, what are we writing in the decimal, right?
In decimal, please.
2.0453.
Wait, 2.04? Wait, I think you get it. Yeah, I got that. I think you're wrong.
I got 117 something.
Miss, you're wrong.
You're wrong because we all got the same shit.
That's wild. All right, let me try. So I stand corrected. Wow, that is bananas. What did I do wrong here? Who?
This is crazy, actually.
Oh, I'm here now. I don't think I messed up. Give me a second. I voluntarily say that this number that I wrote down was wrong. It's because we're answering the wrong question.
Come on, miss.
All right, this is the radian measure. What does the question ask me for? How many degrees will the larger gear rotate? So what do we need to do with this answer?
You do multiply by 180 over pi.
Multiply it by 180 over pi. So go ahead in your calculator. You still have that number saved. Just press multiply 180 divide by and then use the pi button. Ha.
117.
180 over what?
Pi.
117.187.
There's where I got the 117 from. I was about to say I fully used these notes last year and with these like my key right here, and no one stopped me, which would be absolutely wild. So they're just like, she's wrong and that we're not going to tell her. Moral of the story, number 1, the problems can use the same arc length. Moral of the story number 2, make sure you know what question you're answering so that you give me the correct degree or radian. Yes?
Why did you multiply the 2.0?
Great question. I should probably show my work. So since we want radians to be converted to degrees, I'm going to multiply by pi over 180. I'm sorry, 180 over pi. Ugh. Just losing my mind.
Miss, it's a Monday.
The sad thing is it's a Tuesday. Okay. All right, area of a sector. Last little bit for today.
Oh my miss.
The area of a sector. Now, this word sector you may not have used in a while, but basically the sector of a circle is literally just like the entire pizza slice. So we're just going to find the area of a portion of a circle. That's what's called a sector. So a sector of a circle is the portion of the interior of a circle intersected by a central angle. The area of a circle, of a sector of a circle with radius r, and central angle theta is given by the following formula. But again, theta is measured in radians. This is why radians are important. The area of the sector will be equal to the radius squared times theta divided by 2. Joseph, what's your question?
Can you say it all that again? I didn't understand.
Okay, so the sector of a circle is like the part of a circle. So if I was asking for a semicircle, like half of one, that's a sector of the circle. If I wanted a quarter of a circle, that's a sector. We're basically finding the area of the entire pizza slice, not just the length of the crust.
You used a lot of tricky words.
I did.
If this was ChatGPT, I would put, can you do it dumbed down version? So
Want the ChatGPT dumbed down version?
Yes.
Okay, when we were doing arc length, we're finding the length of the crust.
Yeah.
When we're doing sector, we're looking at the entire pepperoni pizza. See? Oh my gosh.
Yeah.
Incredible. All right, so let's find the area of a sector-shaped field. A center pivot irrigation system. So if we're not farmers here, so that's that thing you put in your yard and it goes.
Oh, yeah.
Okay, this is a large version of that for like actual farming. It's called a center pivot irrigation system. It provides water to a sector-shaped field. Because again, it's only going like a little section, right? It's a sector.
Wow.
Okay, we're going to find the area of the field which we are watering. We have the diagram here. The things we need for this formula are radius. What is the radius length of this pivot irrigation system? 321 meters. We also need an angle theta. What is the angle?
15 degrees.
Ooh, but I don't want it in degrees. Let's convert it to radians. Bless you. So we do, bless you again, 15 times pi over 180. And we leave it in terms of pi so we don't round in the middle of the question. 15 divided by 180 back as a fraction.
0.08.
But back as a fraction.
Oh, yeah.
1 over 12, so this is pi over 12. That is all we need to find the area of this sector. Because area is equal to the radius squared times theta. That is not enough room for me to write that entire number. Radius squared times theta, all divided by 2. Well, the radius is 321. Theta is pi over 12. Since we're at the very end of the problem already, go ahead and use the pi button and find the area that this sprinkler is watering.
As a fraction?
This one will be a decimal because we're at the end of the problem.
0.018.
Make sure it's in terms of pi.
This one's as a decimal.
As a decimal. 4 decimal points, please. It's a large number. 13,488.0354 square meters. Like I said, this is not one that's probably in your front yard. This is like a farmer's equipment. You got that?
Yes.
Amazing. So we have 2 new formulas today. We have the formula for the arc length, pizza crust. We have the formula for sector, whole pizza pie slice. Is that better?
That does make a lot of sense.
Okay, bet.